Let us discuss comparators now. The basic thing you should know about a comparator circuit is that comparator is always operated in open loop conditions. Okay, so till now all the circuits we have discussed have been operated in closed loop. This is an open loop circuit. Okay, next, I have already told you that AOL, the open loop gain, is very high in gains of open loop. So taking these assumptions, now we are going to discuss our basic comparator circuit. Now let us start with the non-inverting circuit first. This inverting and non-inverting depends upon which terminal you are giving the input. So as you can see here, we are giving Vi at the positive terminal, so this will be a non-inverting comparator. Now observe here that since there is no feedback loop, the output can go to any value. This can be infinity theoretically. Like in practically, what happens is it is limited by these two values. I explained this already while discussing the output swing. This is also called Vsat, as we have seen already. So the maximum value of the output swing will be plus Vsat to minus Vsat. Okay, so here the thing is, this is a simple subtractor circuit without the resistors, of course. So if Vi is greater than V reference, where Vr is V reference, this will be equal to positive Vsat, and Vi less than V reference, this will be equal to negative Vsat. Okay, because remember the gain is very high, so the output can go to any value, but since it is limited by these values, the supply voltages, it can go only up to Vsat and minus Vsat. Now this is the formula you have to use for AOL, open loop gain. See here from this circuit, you can see even for the smallest value here, suppose this value of Vi also, this voltage will be Vsat. Even for the smallest negative value here, this voltage is minus Vsat. So AOL will be the minimum value of input which will make the transistor into saturation, the op-amp into saturation, is calculated here. Okay, now there is another thing called a trip point. A trip point is nothing but the point at which the op-amp output shifts from negative to positive. For example, the trip point in this case is 0. Okay, so this change, the point of change, is called a trip point. In case of a practical op-amp, the change won't be sharp, it's going to be slow. So that there is no specific trip point, we have 2 points called A and B. Okay, next, this trip point need not always be 0. We can always move the trip point. How to do that is by changing the reference. See, in this above circuit, we assume that the reference point is what? 0. So we got the trip point as 0. But here, if you take a practical circuit, the reference point need not be 0. Now I am keeping some reference point here other than 0. So now the trip point can be, say, here, because I am moving the trip point towards the positive side, so this will be the trip point. Similarly, if I keep a negative reference voltage, say minus Vr, then I can move the trip point to negative side. Okay, next, now we'll discuss a inverting comparator. The concept is same, just the input is applied to the inverting terminal, and here observe that the output, this is a positive cycle, but the output is negative Vsat, because we know that in an inverting comparator, this will be 180 degrees out of phase. Okay, so in this case, the positive half cycle will correspond to the negative cycle, and the negative half cycle will correspond to the positive cycle. Okay, now all these things were the ideal amplifiers, ideal comparators. Now we will be discussing a practical comparator. In a practical comparator, there are diodes introduced here. The only difference is the introduction of diodes here. Don't be worried about this circuit, it is nothing but the same circuit, just the connections have been made in a different way. Instead of giving the reference directly, we have used a potentiometer, that's it. Okay, there is no change. If you give a VR directly, there will be no difference. Okay, the diodes are used here because, as I told you, even for a smallest change, like I have explained there, even for this kind of smallest change in the input, the output will be Vsat. So the thing is, we don't need to apply a large voltage, even the smallest voltage is enough. These diodes, as you know, the voltage across the diode, V gamma, cutting voltage, if you remember, is always 0.7. Suppose I am taking silicon, okay, is always 0.7. So these diodes will keep the input voltage to always 0.7, plus 0.7 or minus 0.7. That's why we are using two diodes. So if the input is negative, this diode will be working, and if the input is positive, this diode will be working. Okay, so the input range is always in this range. This helps in controlling damage of the operational amplifier. If we apply a large voltage, this diode will restrict the voltage, and hence the op amp will be safe. Okay, so the output of the practical comparator will be like this, as we have already seen. Now we will see some of the applications of the operational amplifier. Zero crossing detector. As we have seen, when TP equal to 0, if we keep TP equal to 0, we can have the zero crossing detector. Similarly, level detector. The op amp will give an output as this square wave, right? So a level can be detected by having some value of Vsat. This level is Vsat, right? So we can choose the value. So that is the level. This is also equivalent to the sample and hold circuit. Sample and hold circuit is nothing but one value is sampled and this value is held till the next sample comes. That sample again held, then till the next sample comes. Okay. And a pulse generator, of course, because any sine wave is getting converted into a pulse, so it can also be used as a pulse generator. That's all for comparators.